So when you go to try to get to gmail.com and your browser realizes it can't get out to the web, it just gets redirected to a local server, which is really running a local copy of Gmail or whatever it may be. That's the local server component. It has a database. This is a full relational client-side database. It uses SQLite as the format, and HTML5 also uses that same format for the database. Just a very simple, really stripped down relational database, very basic. And then it also has this worker pool, because everything that it does is very JavaScript intensive. You know, we are really moving to a world where JavaScript is really driving everything on the web. And so they have kind of this separate worker pool to handle that so that it doesn't slow things down. So if you've turned on Gears, the way that it actually works is when you first, so you install it, it's a browser plugin. This is not something that's there by default. It's available for a number, I'd say most desktop browsers have a version of Gears available. When you first access a site, you must actually explicitly say, yep, I want Gears to be enabled, because it's going to create a local relational database on your desktop. I kind of like that aspect. Normally, I don't like leaving security decisions up to the end user, but here, you know, we're actually storing data on the client side that I'm sure most users wouldn't have any idea that that was happening. So I kind of like the fact that it lets you know that that's happening. And then the database that it creates, SQLite's really simple. All it really creates is just one file on your desktop, and it's always in the same location. I think the next slide actually, yeah, show the locations. And it's just this binary file format, but again, a lot of the stuff is in text, and there's many readers out there. I forget the name of the one I usually use. I think it's called just SQLite Database Browser is actually, I think, the name, just a SourceForge project. So it's an easy way to open up a SQLite database file and actually see it in a user-friendly format, and you can run queries against it. Standard relational database stuff, so you know all the SQL statements that you're familiar with you can use here. But of note, it stores these files in both, it's dependent upon both the OS and the browser that you're using. So it will store it in different places regardless. And that's just important that, you know, if somebody wanted to conduct an attack to pull that file, it is always in a predictable location, but based on both the browser and the OS. Yeah, by the way, if you have friends that do this to you, they're not actually your friends, so. So let's talk about client-side SQL injection. So we've always thought of SQL injection as a server-side attack. You know, the relational database sits on a server somewhere, and if that web application is vulnerable, now I can actually query that database. I can read to it, I can write from, or I can write to it, I can read from it. We've always thought of that as a server-side attack. Well, now we have a relational database that actually sits on the client side. So this opens up a whole new world of possibilities. I mean, can we conduct client-side SQL injection? Well, the answer is yes, but let's kind of talk through it. So the way Gears works is that it's JavaScript driven. So in my web page, I call a JavaScript library and then, you know, send my JavaScript functions to either create a database or read from an existing database or write to it. And you know, so long as it's there, then my browser is physically querying this database that's on the client side. Everything is driven by JavaScript. So if I had the ability to get JavaScript into the page that you were going to, then yes, that's how I could conduct client-side SQL injection. And what's really important about that is that, hey, obviously cross-site scripting, very prevalent vulnerability. A lot of sites have it. So if they have that vulnerability, now I can actually query from a client-side database. I don't need a vulnerability per se in the actual SQL statement and the way it was written, the way traditional SQL injection would work. You could have done all of that stuff in a very secure fashion, but simply because, you know, you've implemented an otherwise secure technology on an insecure platform, then I can attack you. And everything that I'm saying about Gears will also apply to HTML5 because it's a very similar setup. It uses SQLite as the back end. It's all JavaScript driven as well. We'll talk about HTML5 in a second. So just one thing, when I did this, I thought, people are going to say it's a theoretical attack. So I said, well, how hard can it possibly be to go find a site that's using Google Gears and also has cross-site scripting? Surprise, surprise, not very hard at all. It took maybe 30 minutes. So here's one site that I found, and I used them as, to talk about it because they were fantastic. I really want to take my hat off to them because I told them about it, they fixed it right away, and they were even kind enough to give me a year of free service. So good for them. Because I'm sure many of you have been in that situation where you go to report a vulnerability to someone and they just, make your life hell and tell you they're going to sue you and all kinds of things. These guys said, thanks, really appreciate that. So, I'm talking about a vulnerability that they had, but I just want to go out of my way to say that not only did they fix it and fix it very quickly, they handled it in a very professional manner. So they had what was Paymo.biz, or is, it's actually still around. It's basically a time tracking web application. So your guys are out in the field working, you do consulting work, so you bill your clients by the hour, and this allows them to keep track of their time. So Gears makes a lot of sense for them because, hey, somebody's out in the field, they may not have internet access, so they used Gears to offline enable their web application. So I found that they were vulnerable to cross-site scripting, and so this is just to let you know what would need to be injected to kind of walk you through it. So in this case, just because of where the vulnerability was, I had to close off that paragraph tag. That's not standard, that's just specific to that implementation. So Gears is not built into the browser. It is a browser plugin, and so you have to call in the library that it uses, the JavaScript library, so no big deal, just call that. In this case, I just took it right off the Google site. I have to open the database, and normally when we deal with SQL injection, a big challenge related to the attack is that I have to understand the DB structure. I have to know the names of the tables and the columns and the data types. This is a totally different world. I don't have to guess the database structure using all the tricks that SQL injection typically requires, because if I want to know what the database structure is, I just go visit the page myself. It creates a copy of the database. I know all this stuff. So it's really a lot easier from an attack perspective. So even though it's got that ugly name for the database, I already knew what it was, because all I did was visited the site myself, created the database, I saw that. And then once I've done that, once I've opened the database, it's just standard SQL queries. In this case, I just said, hey, read everything from a particular table. Again, I didn't have to guess the name of that table. I already had that information. And just to show that it worked, I just ended up in that case popping it up on my screen. But from an attacker's perspective, it would be very easy to inject that and do something behind the scenes. Let's say, make an image request to your evil server and just have all the data in a GET request so it shows up in your server logs, or email it to yourself, or do something. So you could really do this in attack. Somebody goes through, is browsing their site, and has no idea that they've just been attacked. Meanwhile, you've just taken all of the data that is stored on their client-side database, and you've been able to access it. And it's really, in this particular case that I'm talking about, it's enabled by the fact that cross-site scripting is there. And hey, if you believe some of the stats that are out there, I really like White Hat stats. Their last report, 66% of sites had cross-site scripting vulnerabilities. And these are companies that actually care about security because they're paying White Hat to review things. So I don't think there's too much argument that many sites are still vulnerable to this issue. But what's interesting to me is Google did a really good job of creating a SQL structure that wasn't vulnerable. So if you write your SQL query in the correct way, it's not vulnerable to SQL injection. But because everything's driven by JavaScript, it's the fact that there's a cross-site scripting vulnerability on this that makes it the whole thing vulnerable. So it's this lesson that we've never seemed to learn as an industry, that you can take great technology, but if you put it on an insecure architecture, everything falls apart. It doesn't matter. So just to compare SQL injection and client-side SQL injection, so what are the differences? Well, as mentioned, in traditional SQL injection, a real headache, a real challenge, especially if we're dealing with blind SQL injection, is figuring out that database structure. And so I have to send all these queries to create error messages and get table names and do all these little tricks. I don't have to do that in client-side SQL injection because, again, I just visit the page, creates a database, I'm good to go. SQL injection, that's an online attack because I have to get to the server. In theory, we could actually do an offline attack. A little tricky, but I think that's a neat aspect of it.